Imagine looking up at the sky and seeing the sun transformed into a perfect ring of fire. Not a sunset, not a storm, but a blazing circle suspended in daylight, sharp and unnatural. The world around you does not fall into darkness, yet something feels wrong. The light changes, the air shifts, shadows stretch into razor-thin shapes. For a brief moment, reality seems rewritten. You may have heard of total solar eclipses, when the sun disappears completely. But this is different. During an annular solar eclipse, the moon does not fully cover the sun. Instead, it leaves behind a brilliant ring of sunlight burning around its silhouette. It is beautiful, yes, but also deeply unsettling. Your surroundings react in subtle ways. The brightness drops, but not enough to become night. Colors fade slightly. The temperature may dip. Animals grow confused. Birds hesitate mid-flight. It feels like standing inside a cosmic experiment, where the rules of light and shadow are temporarily rewritten. And yet, despite the dramatic appearance, nothing supernatural is happening. This phenomenon is the result of orbital precision, distances, angles, and motion aligning perfectly in space. It is geometry on a planetary scale, unfolding above your head. So what really happens if you experience an annular solar eclipse? What changes in the sky, in the environment, and in your perception? To understand that ring of fire, we must begin with the mechanics that make it possible. An annular solar eclipse occurs when the moon passes directly between Earth and the sun, but appears slightly too small to cover the sun completely. Unlike a total eclipse, where darkness briefly consumes the sky, an annular eclipse leaves a bright outer ring visible. That luminous circle is why it is often called the Ring of Fire. The reason lies in the moon's orbit. The moon does not travel around Earth in a perfect circle. Its orbit is elliptical, meaning its distance from Earth changes constantly. Sometimes it is closer, sometimes it is farther away. When an eclipse happens while the moon is farther from Earth, it appears smaller in our sky. At that greater distance, the moon cannot fully block the sun's disk. Even at maximum alignment, sunlight escapes around the edges. The result is a narrow, blazing halo surrounding the moon's dark center. It is not darkness, but filtered brilliance. This alignment does not happen everywhere at once. Only a specific path across Earth experiences the full annular effect. Observers outside that path see only a partial eclipse, where the moon appears to take a bite out of the sun. Experiencing an annular eclipse means standing in the exact region where celestial mechanics align with breathtaking precision. But beyond the visual spectacle, subtle physical changes begin to unfold. Changes in light, temperature, and perception that transform an ordinary day into something extraordinary. The story of an annular solar eclipse begins long before you look up at the sky. It begins with motion, constant, silent motion. Earth orbits the sun at nearly 30 kilometers per second. The moon orbits Earth at just over 1 kilometer per second. These motions are steady and predictable, governed by gravity. Yet because their orbits are slightly tilted and not perfectly circular, perfect alignment is rare. Most months, the moon passes slightly above or below the sun from our perspective. Only when the geometry aligns precisely do we witness an eclipse. The moon's orbit is elliptical, meaning its distance from Earth changes by tens of thousands of kilometers over the course of a month. When the moon is closest to Earth, it appears larger in the sky. When it is farthest away, it appears noticeably smaller. That difference in apparent size determines the type of eclipse we see. If the moon is close enough, it can fully cover the sun, producing totality. If it is farther away, its disk is too small to block all sunlight. Instead, it leaves a thin ring of solar surface visible. That ring is not symbolic or mystical. It is the visible edge of a star 93 million miles away, partially obscured by a smaller body caught in orbital motion. What makes this event remarkable is not chaos, but precision. The alignment must be exact along a narrow corridor across Earth's surface. Move a few dozen kilometers outside that path, and the ring disappears, replaced by a partial eclipse. This narrowness reveals the scale of the geometry involved. The moon's shadow stretches thousands of kilometers into space, but narrows to a thin line when it touches Earth. Standing within that line places you in a temporary intersection of cosmic paths. The ring of fire above you is not an illusion. It is the visible evidence of orbital mechanics functioning with extraordinary accuracy, reminding us that even dramatic celestial events are governed by predictable physical laws. As the moon begins to move across the sun's face, the first change you notice is brightness. The reduction is gradual, almost deceptive. Your eyes adjust continuously, making it difficult to perceive the dimming at first. But as more of the sun becomes obscured, the quality of light begins to shift. It no longer feels like standard daylight. The world takes on a flatter tone, as if contrast has been subtly reduced. Shadows sharpen, because the remaining sunlight now comes from a thinner, more defined arc rather than a broad disk. During annularity, the sun never disappears entirely. That persistent ring continues to emit intense light. Unlike a total eclipse, where the sky can darken dramatically, an annular eclipse produces a strange half-light. It is neither day nor night. The environment resembles late afternoon, but the sun is high above. This contradiction confuses the senses. Your brain expects a certain relationship between brightness and solar position. When that expectation is broken, the world feels unfamiliar. The sharp ring of sunlight also alters shadow behavior. Small gaps between leaves can project dozens of miniature crescent shapes onto the ground. These natural pinhole projections multiply across surfaces, turning sidewalks and walls into patterns of tiny eclipses. The phenomenon is simple physics, light passing through small openings. Yet the effect feels surreal. For several minutes, ordinary surroundings transform into an optical demonstration of celestial alignment. It is not just the sky that changes. It is the way light interacts with everything around you. Although the sun is never fully covered, the partial reduction in solar radiation has measurable effects. As sunlight decreases, surface heating slows. The temperature drop during an annular eclipse is typically modest, often just a few degrees, but it can be noticeable, especially in dry climates. The cooling is temporary and localized, yet it reveals how sensitive Earth's surface is to changes in solar input. Air currents may subtly shift as the ground cools unevenly. Warm air rising from heated surfaces weakens, altering small-scale convection patterns. In some cases, wind speeds decrease briefly. These atmospheric changes are not dramatic storms or visible disturbances. They are quiet adjustments within the boundary layer of the atmosphere, triggered by a temporary dip in energy from our star. Wildlife sometimes reacts more visibly than the atmosphere itself. Birds may quiet down. Insects adjust their activity. Animals that rely on light cues can display brief confusion. These responses are not universal, but they demonstrate how biological systems are finely tuned to daily light cycles. When the sun's output shifts unexpectedly, even for minutes, ecosystems respond. Standing beneath an annular eclipse means witnessing not only astronomical alignment, but also Earth's subtle environmental sensitivity to solar change. Beyond physics and atmosphere lies perception. Human vision is highly adaptive. As brightness decreases, your pupils dilate. Your brain recalibrates contrast and color balance automatically. This adaptation can mask how much sunlight has actually diminished. Only when you compare the scene to memory do you realize how unusual it feels. The ring itself exerts a powerful psychological effect. Fire is associated with danger and intensity. Seeing the sun reduced to a burning halo triggers instinctive attention. Even knowing the science, the image feels primal. It is the familiar sun transformed into something geometrically perfect and visually sharp. The precision of the circle amplifies its impact. There is also a cognitive shift that occurs during rare events. Awareness heightens. People become quieter. Conversations soften. Shared attention moves upward. Experiencing an annular eclipse is not just observing an astronomical event. It is participating in a synchronized moment of collective focus. For a few minutes, millions of people may be looking at the same alignment, connected by nothing more than orbital timing. When annularity reaches its peak, the moon is centered against the sun, leaving a uniform ring of light. This phase lasts only a few minutes at most. The exact duration depends on the observer's position within the path. At the centerline, the ring remains longest. Near the edges, it shortens. Time itself feels compressed because anticipation builds for an event that resolves quickly. Scientifically, the annular phase provides opportunities for studying solar limb darkening and atmospheric scattering. Instruments can measure how light intensity changes across the sun's edge. Though less dramatic than totality, annular eclipses still contribute valuable observational data. They are reminders that even partial alignments reveal information about stellar physics and orbital dynamics. But beyond measurement, the Ring of Fire represents scale. A star over 1 million kilometers wide, partially obscured by a moon 1/4 the size of Earth, viewed from a planet rotating beneath them both. Experiencing an annular solar eclipse is witnessing geometry written across space. Nothing catastrophic happens. The Earth does not tremble. Yet for a few minutes, you stand inside a precise cosmic alignment, a reminder that our everyday sky is the product of constant motion and extraordinary balance.